Modern user experience teams run tight, rigorous studies. They identify exact friction points frustrating their users, package those insights perfectly, and hand them off. Yet, quarter after quarter, the actual user experience remains stagnant. The problem lies in how research teams measure their own success. Tracking the number of studies run, participants interviewed, or reports generated creates a false sense of productivity. You are measuring the volume of work, not the impact of it. When these carefully crafted insights collide with the reality of product backlogs, sprint deadlines, and competing engineering priorities, they get stripped down. A major structural fix is negotiated into a quick cosmetic tweak, or pushed to the next quarter, and eventually forgotten. Millions of dollars are spent generating data, but the end user continues to struggle with the exact same broken interface you tested 6 months ago. Delivering a report is not the terminal goal of a researcher. Shipping a fixed experience is. If you cannot prove your recommendations made it into the live product, you cannot prove your research has any value at all. In retail supply chains, the term breakage describes inventory damaged or lost before it ever reaches the customer. In UX research, breakage is the value that leaks out between your readout and the final product release. Because most organizations do not formally track whether specific recommendations are implemented, product teams operate on hope. Researchers hand off their findings and simply hope the designers and developers will prioritize them. Operating on hope carries a severe operational cost. The organization wastes budget treating symptoms instead of root causes. Worse, researchers burn out. They find themselves running the same studies and presenting the same ignored findings quarter after quarter. To expose this invisible loss, research leaders at Cisco developed a mathematical framework called the Recommendation Adoption Score, or RAS. RAS replaces subjective feelings about research impact with hard data. It allows managers to quantify exactly how much of their team's work is surviving the development cycle. You cannot calculate a math equation using a feeling. Insights are too abstract and fuzzy to track through a rigid product pipeline. To measure breakage, we most shift our base unit of measurement. We move from the abstract insight to the concrete, testable recommendation. It must identify the specific problem, the exact evidence, and a clear definition of what a completed fix looks like. Each recommendation is then assigned a specific named owner. Assigning an action item to a general team diffuses accountability. A single product manager or lead engineer must carry the authority to push the fix through delivery. You also have to eliminate ambiguous tracking labels. Statuses like in progress or under review are where breakage hides. These labels allow teams to claim they are working on a fix while actually letting it rot in a backlog. Standardizing the unit of measurement removes the gray area. It forces the product team to either adopt the evidence-based solution or formally admit they are ignoring it. The RAS framework permits only 3 implementation statuses for a recommendation: adopted, committed, and communicated. Adopted means the fix is fully shipped and live for the user. Because not all fixes are equal, they are weighted by impact. High-value fixes tied to core task success earn 3 points. Medium-value friction points earn 2 points. Minor cosmetic polish earns 1 point. Committed means the recommendation has been officially scoped, resourced, and scheduled in a release plan. Verbal promises do not qualify. Crucially, a committed recommendation carries a flat value of 0.66 points, regardless of its potential impact on the user. This mathematical constraint is intentional. It prevents teams from artificially inflating their adoption score by parking high-impact fixes indefinitely on a future roadmap. Even a critical 3-point recommendation is only worth 0.66 until the code actually ships. Finally, communicated indicates that a researcher delivered a clear recommendation, but the product team has taken no action. This earns exactly 0 points. By structuring the weights this way, the matrix inherently values actual, shipped improvements over theoretical product promises. To find the adoption score, we divide the actual user value by the total possible user value and multiply by 100 to get a clean percentage. Take a real-world dataset from Cisco's rollout of the framework. A research team generated 18 recommendations. If every single one shipped, the total possible value would be 36 points. Over the following months, the product team adopted 9 of those recommendations at various impact levels. They committed to 1. The remaining 8 were communicated but ignored. Adding up the points for those adopted and committed fixes gives us an actual user value of 16.66. 16.66 divided by 36 multiplied by 100 yields a recommendation adoption score of 46.3. We map this number against organizational thresholds. Scores below 30 are poor, while scores above 80 are great. A 46.3 lands precisely in the fair zone. A fair score proves that some progress is happening, but the math is objective. More than half of the value identified by the research team bled out before it ever reached the user. A single score diagnoses a specific moment in time, but to make high-stakes resourcing decisions, managers need to see the momentum of the product team. We track two strategic variables to find that momentum. First is recommendation velocity, the average number of new recommendations generated per month over the last 3 months. Second is the RAS trend, the rolling slope of the adoption score over a 6-month period. These two variables combine to form an investment signal matrix, generating clear operational directives. Consider two hypothetical products, B and C. On paper, both have baseline RAS scores around 38. If you only looked at the raw score, you would treat them exactly the same. But mapping the momentum reveals a different reality. Product B has a steady velocity of 3 recommendations a month and a positive adoption trend. The matrix outputs a continue signal. The product team is actively engaging with the research. Product C has a velocity of 1 and a negative adoption trend. The matrix outputs a stop signal. The research is being systematically ignored. With this data, a research leader can justify a difficult management decision. You pull your researchers off product C, halting the wasted effort, and double down your investment on product B, where the insights are actually being utilized. Recall the bottleneck we started with. Valuable insights crushed by the mechanical reality of sprint cycles and competing priorities. Enforcing the RAS framework forces accountability during sprint planning. It clears the blockage by making adoption visible and ignorance mathematically penalizing. This visibility protects your research team. You stop assigning your early career researchers to failing product environments, matching them instead to teams with proven, high adoption track records. Ultimately, this drives a complete operational shift. The primary metric of success for a research organization is no longer did we learn something new? It becomes did we ship a tangible improvement? You can run the most rigorous, methodologically perfect studies in the industry, but if your supply chain is compromised, that data will never benefit the user. To ensure your evidence actually dictates the final product, you must expose the breakage, track the adoption, and drive the outcomes.